Today we are going to talk about conversions. We will talk about US system, metric system, scientific notation, and significant figures. In US we use mile, foot, inches for the length. And we know for 1 mile we have 5,280 feet. So in 1 foot we have 12 inches. If we go internationally, we use centimeter. You have in 1 inch 2.54 centimeter. If you are in US, there is no problem to go from miles to feet to inches. But when you are outside the United States, let's say you are in Paris, you want to buy this sandwich, and you say 1 foot sandwich, he will look to his feet, he measures the size of his foot, and he gives you the sandwich that size. Now, if the guy has very short foot, he will get short sandwich. If his foot is longer, you will get longer sandwich. To standardize this, you have to convert inches to centimeters. Let's say you have 1 foot, which is 12 inches, and 1 inch we said is 2.54 centimeter. In this case, if you say the length of 30.5 centimeter, he will give you 1 foot sandwich. Otherwise, you will not get this measurement. But remember also, in scientific domain, when you go, for example, to medical field or you go to anywhere internationally, you cannot use miles, feet, and inches. You have to go to the metric system. Now we know how to go from miles to feet to inches. We said in 1 mile we have 5,280 feet, and 1 foot is 1 inch, and 1 inch is 2.54 centimeter. Now let's convert this mile to centimeter. All we have to do, we said 1 mile, 5,280 feet times 12 inches. Then you need to go to centimeter, which is 2.54 centimeter. So this is how you get to international side, from mile to centimeter. But remember, in the international system, centimeter is smallest value. Look, we are going to do the math. For 1 mile, we will have 5,280 feet times 12 times 2.54, and then the value in centimeters. So we have in 1 mile 160934.4 centimeter. Did you see? It's very big number with small unit. Now we need to know the relationship between centimeter and kilometers, etc. We said in 1 mile we have 160,934.4 centimeter. What do we see here? We see this number 1 with this number here is too big. What does tell us? This unit in miles is too big compared to this unit in centimeter. So internationally, when we talk about miles in US and we want to convert it to international, we go to kilometers instead of centimeters. If you have miles, you need to look for kilometers. If you have feet, let's say if you have 3 feet or more, you go meters. If you have inches, you go centimeters. We need to find the relationship between kilometer, meters, and centimeter. Once we do that, we can deduct the relationship between miles and kilometers. Because if I know the relationship between mile and centimeter, if I know the relationship between centimeters and kilometers, I will know the relationship between miles and kilometers. To find the relationship between kilometers and centimeters, I would like you to remember this sentence. King Henry doesn't mind drinking chocolate milk. For King, you think about kilometers. Henry is hectometer. Doesn't decameter. Mind is the base unit, which is meters. Drinking is decimeter. And chocolate centimeter. Milk, remember, millimeter. So this is how we remember it. King Henry doesn't mind drinking chocolate milk. Then you go make a table. This table, you start from anywhere, but remember, if you put here millimeter, it will be here centimeter, decimeter, meter, decameter, hectometer, kilometer. This is how we do it. You start with the first milli, centi, deci, meter, deca, hecto, kilo. We said in 1 mile, we had 160,000 and 934.4 centimeter. Now, how you plug this number table? You go to the first digit of the whole number. The whole number means the number without decimal point. Take the first number, the first digit of the whole number, you put it in the unit of centimeter, means you go to centimeters and you put 4. What is in the left goes to the left, what is in the right goes to the right. That means here the first digit of the whole number we said is 160,934. The first digit is 4. I go put the 4. The first digit of the whole number goes to the unit. What is in the left goes to the left. What is on the right goes to the right. To the right we have 4. To the left we have 3. Then we have 9. We have 0. We have 6. We have 1. This is how we plug the numbers in this table. Now it's very easy. I said if I want in centimeter, I just put the decimal point here. That tells me I am in centimeters. This number means is 160,934.4 centimeter. Now if I want to go to kilometer, I go move my decimal point towards kilometer. Remember, don't put the decimal point in the front, because if you put the decimal point in the front, let's say if you put your decimal point here, means you are in the next unit. So make sure you keep the number in the unit, and behind the number put the decimal point. So let me repeat. We said 160,934.4 centimeter. It will be exactly 1.609344 kilometers. So this is how we do it. If I want decameter, I go to DA. This is what that means. I put the decimal point where is decameter, and I take this one off. That means this means 160.9344 decameter. This is how we write. B 1060.9344 decameter. So this is how we do it. Now, if I want it in decimeter, I just move my decimal point. Where is decimeter? Move it here. Decimeter is this, and I put the decimal point behind the number. Remember, if you put your decimal point in the front here, means you are in meters. If you put it in front, means you are here. Make sure it's behind the number. Okay. So if I want it in decimeter, I just, it will be 16093 3.44 decimeter. This is how we do it. Let's say if I have 57.6 kilometer. Now, what I do here, I go to the first digit of the whole number. The whole number is 57. The first digit is 7. Don't go to 5, it's 7. This first digit of your whole number goes to kilometers. Then what is in the left goes to the left. What is in the right goes to the right. Once you do that, then you fill the empty spot with zeros. Let's say here 7, it goes to kilometers. I put 7 here. Then I put 5 here. Then what follows 7 is 6. Then I fill the empty spot with zeros. So if I want it in kilometers, what we said, I put the decimal point here. Okay, it'll be 57.6 kilometers. Now, if I want it in decameter, I go plug my decimal point here. This is my decameter. It will be 5,760 decameter. If I want it in, I don't know, in millimeter, I put my decimal point in the back of this. Then I will count how many zeros I have. It will be 57,600,000 millimeter. So this is how we do it. You go to the whole number, put the first digit of your whole number in the unit. What is in the left goes to the left. What is in the right goes to the right. And then fill the empty spots with zeros. Then you move the decimal point to the unit you are looking for. We said in 1 mile, 5,280 feet, in 1 foot, 12 inches, in 1 inch, 2.54 centimeter. This you need to remember. Then if you want, you want to remember this 1 mile is 1.64 kilometers. And another thing you need to remember is the sentence they give you. King Henry doesn't mind drinking chocolate milk. Let's talk about significant figures. They take this number, 5,678, non-zero digit. So the number of significant figure, you just you have 4 significant digit or significant figure. Now, if we have, let's say, for example, this 0.0056, these zeros, we call them leading zeros. They don't count. That means the number of significant figures will be just 2 significant figures. Now, if the zeros are in between the numbers, now they count, you will have 4 significant figures. In this case, if we have zeros in the back and there is no decimal point, for example, in this case, so the number of significant figures are 3 significant figures. Now, in this case, we have a decimal point here. If there is decimal point in the front, the trillion zeros, they count. This, it will be 5 significant figures. So this is how we count them. Now, let's say if I have 0.005670. In this case, this is 0, it counts. Now, how many significant figures? The leading zeros, they don't count. The trillion zeros, they count if there is a decimal point. So in this case, I will have 4 significant figures. Trillion zeros, if there is no decimal point, they don't count. If there is decimal point, they count. Now we are going to talk about additions when we have significant figures. Let's take 1.2 plus 3.45 plus 6.789. The answer will be 11.439. How many significant figures we have after decimal point? So I have on this one 1, this one has 2, this one has 3, 11.4. We take the least significant figure after decimal point. I do my math with my calculator, and then I go to the least significant figure after decimal point. Now, let's do another example. I have 1.2 plus 5.8, 6 will be 7.06. So what I see here, I have list. This one has 1, This one has 2. Then I keep the list. List will be 7.0. 7.0, but remember after 0 I have 6. It will be just 7.1. That means if you have a number 5 or more, you move 1 up. So it will be 7.1. Now let's say we have the difference. An example, 78.967 minus 4.53. We do the math normally with calculator. We drop it. It will be here 74.437. Okay. Again, the same principle we used for addition, we are going to use it for the difference. 3 significant, we have 2 significant, we need to keep just 2 significant. Now remember this, I stop here. Once I stop here, I have to look in the back. The back I have 7, then I move up 1. Then it will be 74.44. So we go to the significant figures. After the decimal point, we count how many significant figures we have after the decimal point. When we do the calculations, we take just the least significant figures after the decimal point. For multiplication, let's take this example, 678.6 times 4.34. We do the math with calculator. Once we found the answer, we just plug it there. It will be 3,623.724. This is the answer from the calculator. But now we have to look for multiplication, the whole thing. This one has 3 significant figures. This one has 4 significant figures. Remember, for multiplications and divisions, you look for the whole number that. So in this case, I have 3. I have to keep 3. So what I see here, I see 4 in here. Now in this case, I will forget about that, and I have to keep just 3 significant figures. Now for these 3 significant figures, what will be this answer? It will be just 3,620, because this 3 is closer to 0. If we were at the number 5 or more, then we move up to 3. It will be 363. But in this case, we need to keep just 3 significant figures, and this is what we will have. It will be just 3,620 instead of 3,623. We keep the least significant figure. Remember, last time we said the trailing zeros, when there is no decimal point, they don't count. So all we have here is 3 significant figures. Okay, let's do this one. 786.934 divided by 6.78. Now we have here 3 significant. Here we have 6. So we keep the least significant figures. First, we do the math with calculator. We'll drop the value like this, what you see on your calculator. Here with 116.066. 6696, etc. So now we drop the value like it is with your calculator, and then look to the least significant figures. Now in this case, I will just keep 3, it will be 116. Now this is the answer for division. Scientific notation. Let's take this example, 5,000. In scientific notation, 5,000 means that my decimal point is in the front here. I move once, twice, 3 times. It will be 5 times 10 to 3. This is how we write scientific notation. Let's say if I have 5,600, it will be, my decimal point will be here. 1, 2, 3. It will be 5.6 times 10 to 3. Now this is how we write the scientific notation. We move the decimal point to the last digit. Let's say if I have 5, 6, 7, 8, 9, and then I want it in scientific notation. That means like I have 56,789. The decimal point means is here. I move it once, twice, 3, 4. It will be 5.6789 times 10 to 4. So this is how we write scientific notation. Let's say if I want to add these numbers, all these numbers together, what I do mathematically, I look to the power. This power, the maximum power here I have is 4, 10 to 4. That means I need to bring this one to 10 to 4. It means in this case, if I move one more, the decimal point one more to my left, what will be 0.56 times 10 to 4. The same thing here. It will be 0.5 times 10 to 4. Now, once I stabilize the power, I use the rule of addition. So we say the rule of addition, add 0.5 plus 0.5 plus 5.6789. I do my math and I multiply, let's clean this. I multiply by 10 to 4. This is what would be my addition. Once you do that, you use the rule of significant figures. It will be 6.6789 times 10 to 4. But now we need to pay attention. This one, how many significant figures I have? Remember, this one has 1 after decimal point, this one after decimal point, this one has 4. I will take the least significant figures after decimal point. Least significant figures, it will be just 1. In this case, what I will have? I have 6.6. I need just one significant figure that is closer to 6.6. Now remember, if I take 1, the closest to 6.6, it will be 7. In this case, it will be just 7 times 10 to 4. This is how we add the significant figure when we have scientific notations. So we stabilize the power, then we go add and use the rule of addition. We said we take the least significant figures after the decimal point.